Hi, hello, welcome back to Homeschool. This is your class 10 mathematics, NCERT or CBSE board. Today in this session, I am going to discuss areas related to circles complete chapter in one shot. Let's begin. Whereas in our formulas videos, this chapter formulas are not available in it. So I am going to discuss first the formulas of this chapter, then I'll continue the problems. Right? You can see a circle here. Circle center O. Right? Center is represented by the letter O. And what is the outer ring called as? It is a circumference of a circle. What is circumference of a circle formula? It is 2 pi r units. 2 pi r units. And what is the region? What is this region called as? It is area. Area of a circle. Area of a circle is equal to pi r square units. Next, suppose if I join a line from center of a circle to a circumference. What is this line called as? Radius. Let me draw two radius. Right? This is radius. This is also radius. And you can see arcs. Can you see the arcs? Here you can see two radius and you can see a small arc here. Can you see? From here to here it is an arc. And what about this arc? This is also an arc. Right? Whereas this is minor arc. And from here to here it is major arc. Minor arc, major arc. Formulas. What formula we need here? Length of minor arc or major arc. You don't confuse with the formulas. Suppose if I take this sector angle is theta. Sector, the region bounded by two radius and a arc of a circle is called as a sector. This is minor sector, this is major sector. Right? Now, what is the length of minor arc? Look here, this angle is theta. What is the complete angle of a circle? 360 degrees. Right? Now, remember the formula in this way. Theta by 360 degree into this arc. Where is this arc on a circle? That is on the circumference of a circle, right? What is circumference of a circle? 2 pi r. Length of minor arc is equal to theta by 360 into 2 pi r. This is only length of minor arc. If you know angle and radius, you can substitute. You are going to get the length of minor arc. Then what about major arc? What about major arc? See here. This angle. What is this angle here? This angle theta set. But complete angle is 360. Then this angle might be 360 degree minus theta. Right? That only right here. Length of major arc is equal to 360 degree minus theta by 360 degree into arc. Circumference you should remember 2 pi r. Right? Now suppose if this angle is theta given. Look here. If this angle is theta given, then this angle must be 360 degree minus theta. Suppose if this angle is theta, this will be 360 minus theta, right? So, at that moment, you change your angle. In minor arc, what is the angle you can see there? 360 minus theta by 360 into 2 pi r. And now in major angle, what is the angle here? Theta. So, instead of 360 minus theta, right there, theta by 360 into 2 pi r. These formulas are applicable when minor sector angle is theta and the other angle is 360 minus theta. Then you can directly write these formulas. Then what is the length of arc means? From here to here length means theta by 360 into 2 pi r. Then from here to here what is the length means? 360 minus theta by 360 into 2 pi r. Next coming to sector. Can you see here? What is the area of a minor sector? Area of a minor sector. This is small sector, right? Look here. What is a sector? The region bounded by two radius and an arc in a circle is called as a sector. This is small one, so it is called as minor sector, and this is major sector. Right? Now, how to find this area of a sector? Right here. Area of which sector? Minor. Area of minor sector is equal to, what is the angle here? Theta. Theta by 360 degree into, I am talking about area of a sector. So area, where it is? Area in a circle, this one, right? So area of a circle you should remember. Theta by 360 into pi r square. When this angle is theta, then it is theta by 360 into pi r square. Then coming to area of major sector. Area of major sector. What is the angle here? 360 degree minus theta by 360 degree into pi r square. Right? This angle, according to the problem, you change numerators. Right? Suppose if this is 100 given, then 360 minus 100 will be this angle. Then coming to next formula. So let me draw a chord. Chord, it is a line segment joining 2 points of a circle. Now this chord divides the circle into 2 parts. And what are those parts called as? Segments. This is minor segment. A chord divides a circle into 2 segments. Minor segment, major segment, which includes center, that is called as a major segment. Which does not include center is called as a minor segment. A chord divides the circle into 2 segments. Minor segment, major segment. Sector is also same manner you have seen. Minor sector, major sector. Right? Now I am talking about this segment. 2 more formulas you should remember. What is that? Area of minor segment. See here, this is minor segment. This area I want. Observe carefully. Look here. What is this? This is a sector. This is a chord. I need this area. If I need this minor segment area, how can I get this? Observe carefully. In area of a minor sector, subtract triangle. You can see a triangle there, right? In area of minor sector, minus area of a triangle will give you minor segment area. That only let me write here. Area of minor segment is equal to area of minor sector minus area of triangle. Area of triangle. That is nothing but what is area of minor sector? Theta by 360 degree into pi r square minus area of a triangle formula. Half into base into height. Put with the brackets. Right? This is the formula for finding area of minor segment. Once again, how do you get area of minor segment? In area of a minor sector, Subtract area of a triangle. Yeah, we're going to get minus segment area. Next, what about area of major segment? When I talk about major segment, again you should remember some other figure, right? This is minor segment. Now I don't want minor, I need major segment area. This area I want. How will you find that area? Observe carefully. In figure only you can frame the formula. In area of a circle, remove area of minor segment. That's it. You are going to get area of major segment. Frame here. Area of major segment is equal to area of circle minus area of minor segment. That is, what is area of a circle formula? Pi r square minus, see the same thing, write it in bracket again. Area of minor segment is theta by 360 degree into pi r square minus half into base into height, right? This is the formula for finding area of major segment. And still some more formulas you need to remember here. Area of a ring. If you want ring formula, already I discussed in that formulas video, area of a ring. If this is small r and if this is capital R, from here to here it is capital R, then what is area of this ring? And this area I want. Then what is the formula? Pi into capital R square minus small r square. And some more formulas you should remember. Area of a square, side square. Area of a rectangle, length into breadth. And area of a trapezium, half into height into a plus b. Right? So these all formulas we may apply some or the other place in this chapter. So let's have a quick recap of all the formulas. Circumference of a circle, it is 2 pi r. Area of a circle, pi r square, square units. Next, length of minor arc, theta by 360 into 2 pi r. Length of major arc, 360 degree minus theta by 360 into 2 pi r. Area of minor sector, theta by 360 degree into pi r square. Area of major sector, 360 minus theta by 360 into pi r square. Next, area of a minor segment. In area of a minor sector minus area of a triangle will give you that formula. Theta by 360 degree into pi r square minus half into base into height. Right? Area of major segment. In area of a circle, remove area of minor segment. That is pi r square minus theta by 360 degree into pi r square minus half into base into height. Okay, these are very important formulas, children. Please don't by heart these formulas, because in your chapter you need to frame the formulas, right? And the theta value is not fixed. At that time you should see the theta value carefully and then frame the formula. Okay, is this clear? Let's read the problem. In a circle of radius 21 centimeter, an arc subtends an angle 60 degrees at the center. Find the length of arc. According to this question, what you need to find? You need to find the length of this arc. Say which arc we are going to find, minor or major? How could we know? See there, they have given 60 degree angle, an arc subtends. That length you need to calculate. That length means 60 degrees, it will be minor arc. Right? Suppose if it is 300 degree, it will be major arc. Right? Now, given data. Given radius r r is equal to 21 centimeters and theta is equal to 60 degree. Length of arc you can write, length of only arc you can write or minor arc also you can write. By observing the figure you should say it is the length of minor arc. If you want you can write minor arc also here. So what is the formula you remember? Theta by 360 degrees into 2 pi r. Arc is on circumference. So remember circumference formula. Now let us substitute. Theta value is 60 degree by 360 degree into 2 into pi value 22 by 7, r value is 21. Now cancel. 66 360, 7 3s 21, 3 2s 2 1s 22 1s 22 and unit is 22 centimeters is the length of arc. Now what they have asked, we need to find length of minor arc. Now I am going to take another question of same measurements, that is radius 21 centimeter, theta 60 degree. I am going to find length of major arc. This is minor arc, but they did not mention. If you want you can mention that one only. When this is given and if they ask to find major arc, if they ask to find major arc length, if they ask, then what is the formula? 360 degree minus theta by 360 into 2 pi r. What is theta value given? 60 degree, right? 360 minus 60 by 360 degree into 2 into 22 by 7 into radius 21. 7 3s are 21. And here 360 minus 60 will be 300 by 360. 0 0 cancel. 3 10s are 3 12s are. Again 2 5s are 2 6s are. Into 2 into 22 into 3 left, right? 3 2s are. Again 2 1s are. And now we are left with 22 into 5. That is 110 centimeters. 110 centimeters is what? Length of major arc. Length of major arc. So therefore length of major arc is 110 centimeters. Now let me take same question. Same question I am going to put another number 22. What is this 21 22? According to the revision schedule I am taking this as 22. Right? Now what we are going to calculate? The same problem. Area of minor sector. Area of minor sector. Same question children, no change. What is area of minor sector formula? Theta by 360 degree into pi r square. Substitute theta value is, what is the theta value here? 60 degree by 360 into pi 22 by 7 r 21 into 21. Right? 66 7 3s 3 2s 2 11s. That will be 11 into 21. Multiply, it will be 231 centimeter square. This is your area of minor sector. Right? What is this area? 231 centimeter square. Same manner, let us find area of major sector. Questions may be different children. Giving radius and angle may be different, but the method is same. Area of 23rd, area of major sector. Area of major sector is equal to, what is the formula? 360 degree minus theta by 360 degree into pi r square. That equal to 360 minus 60 will be 300. 300 by 360 degree into pi value is 22 by 7 into radius 21 into 21. 7 3s are 0 0 cancel. 3 10s are 3 12s are, and again 2 5s 2 6. Now 3 2s are 2 11s are. What about 11 into 21? We got here 231. And still you have here 5. 231 into 5. Multiply 5. 1155 centimeter square is the area of major sector. Which area, children? This area. From here to here, this area is major sector area. You know, minor sector angle is 60. Therefore, what is this angle means? 360 minus theta you do, you are going to get that angle. That by 360 into pi r square. Okay, is this clear? So, understanding problem is very easy. Don't be panic with this chapter. See, framing formulas, if you remember formula, doing this chapter problems are very simple. Now next, I am using same question and I am going to find area of minor segment. How can you get a segment here? A chord divides a circle into two segments. First, let me calculate the area of this minor segment. If you want, you can take the letters A, B. And if you want, you can take here C, and here you can take D. ACB segment area you want, right? First question in this, area of minor segment. Area of minor segment ACB is equal to, what is the formula? Theta by 360 degree into sector. Sector formula you should remember first. That is pi r square minus area of a triangle, half into base into height. Right? Now, we already done before. What is theta value? 60 degree by 360 degree into pi 22 by 7 into r 21 into 21. 7 3s are 66, 3 2s are 2 11s. That will be, what you got here? 231 centimeter square area you got already before. But now what is extra? Minus half into, please put a bracket here, half into, what is the base of a triangle? AB into height. That means you should draw a perpendicular. Let me draw a perpendicular and mark it E. OE. What is this? Height. Height is how much? OE. Now, do you know what is AB length? Don't know. What is OE length? Don't know. So, first we should find those two and then proceed this problem. Right? Before doing this formula, first try to find what is OE and what is AB. So, for this you should apply trigonometric ratios. Right? Do you remember sin theta, cos theta, tan theta and all? That ratio you are going to apply and find the side. Applying that ratios, you need to find the missing side length. Right? So, first let me do this. Draw a perpendicular. Right? Let me take a right triangle. My imagination, I will take this right triangle outside. This is 21 centimeter. Perpendicular, it bisects the angle also. Total it is 60. Then what about this part? 30. Right? Now observe here, acute angle is here. Right angle, this is hypotenuse. You need opposite side and adjacent side. Opposite side and adjacent side. That means when you want opposite and adjacent, don't go for tan. First, what is given for you? Hypotenuse, right? First, you find any one side. Opposite hypotenuse. What ratio you remember? Sine, right? Theta value is here 30 degree. Sine 30 degree is equal to opposite EB by hypotenuse OB. Sine 30 degree value is 1 by 2. EB, we don't know EB. EB as it is you take by OB 21. EB is equal to 21 by 2 centimeters. Right? Now, observe here, is it enough to apply in formula? Formula, what do we need? Base and height. Base from A to B I want. Not only EB. See here, the perpendicular what you have drawn, it divides the base equally. That means AE is equal to EB. What is EB? 21 by 2 centimeters. Then AE is also 21 by 2 centimeters. Then coming to base, AB is equal to AE plus EB. Write it 2 times 21 by 2 plus 21 by 2. Do LCM. 21 plus 21 will be 42 by 2. That will be 21. Therefore, what is base, children? This is 21 centimeters. Right? Now, still what we need? Height. Height, which ratio you are going to apply? Adjacent hypotenuse. Adjacent. I remember cos theta. Cos 30 degree is equal to OE by OB. What is cos 30 value? Root 3 by 2. OE, we don't know. OE only, alright? OB, 21. Now, OE is equal to 21 by 2 root 3 or 21 root 3 by 2 centimeters. This is what? Height of the triangle. So, if you are able to identify angle here only, you can do directly sin theta cos theta. But I can't get the imagination if you feel. Take the right triangle separately, rough column this triangle. Observe the figure carefully and find the missing side. Right? Now come back to this formula. After doing those only, you should start this formula. Right? Now 231 minus half into what is AB? 21 into what is OE? 21 root 3 by 2. Right? Then this will be 231 minus again here 21 by 2 into 21 root 3 by 2. You can multiply 21 into 21. Just you can multiply here. That will be 441. 441 root 3 by 2 2s are 4. So this, if you want, you can write it as 231 minus 441 root 3 by 4 centimeter square. That's it. You can end up, or you can do LCM and end up. You can stop here also. Right? So therefore, area of minus segment is equal to 231 minus 441 root 3 by 4 centimeter square. Right? Is this clear? So let me give a quick recap of this problem again. Find the area of minus segment. Then you should remember the formula. In area of minus sector, subtract area of triangle. Area of minus sector, theta by 360 into pi r square. Triangle area, half into base into height. Then observe here, we don't know base and we don't know height. So apply trigonometric ratios and find base and height. Then rewrite this formula and then solve them. After finding that, you write the formula and substitute the values. Right? This is what? Area of minor segment. So let me move to the next question in this. That is nothing but area of, now I found here minor segment, right? Let me find area of major segment. What is that? From here to here area I want. Area of major segment. Look here. To find area of a major segment, area of major segment. In order to find area of major segment, you should find first minor segment. Suppose if you understand this, you will be able to find area of minor segment. Afterwards, find area of major segment. So I am continuing the same question. When you want to find area of major segment, if you have that question, first you find a triangle base and height, then apply this formula, area of minor segment you calculate, then coming to area of major segment. You need to continue these all for this question. If they ask only minor segment, up to here enough. Major segment asks, you need to do these all again. Area of a circle, pi r square minus, again you need to write completely. That is theta by 360 degree into pi r square minus half into base into height. Right? Here is equal to area of a circle 22 by 7 into radius is 21 square, 21 into 21 minus. This is area of minor segment. Already I got an answer. As it is, I will write here. That is 231 minus 441 root 3 by 4. Okay. Now this one you calculate 7 3s are 322s are, it will be 66. 66 into 21 multiply. That will be 66. 132 6 8 3 1. 1386. 1386 minus, remove this bracket, 231 plus, minus into minus, plus 441 root 3 by 4. If you want, you can subtract these two. That is 1386 minus 231. It will be 551. 1155 plus 441 root 3 by 4. Up to here, you can end up your answer. This is about the area of major segment. So among these all questions, you may expect 1 or 2 questions and 1 more 4 marks when you are expecting. That question will be in the form of figures. So look here, suppose if you have 4 circles. If you have 4 circles touching each other, each circle having same radii, they will say something. Suppose the side of a square is 14 centimeter. So other than circle shade this region, this area you need to calculate. So frame the formula in this chapter. Imagination is important and framing formula is very important. Observe this figure. What is that, children? I can see a square of side 14 centimeter. So what is area of a square? Side square. That is 14 square. Calculate that answer. Then in this, inside I can see 4 circles of each having same radius. That means, observe here, this circle, this is divided into half first. That is 7 centimeter is the diameter of a circle. Then what about radius of each circle? 7 by 2 centimeter. So frame the formula in order to get this area. How we are going to frame? In area of a square minus 4 times area of a circle will give you the shading region. Same manner, you can expect like this questions. Suppose if this part is shaded, right? So find this part area. Not shaded area if they ask you. What you are going to do? In area of a sector, remove area of a triangle. Right? Same manner, you can expect like this. What is this? If this is perpendicular, what do we call it? It is quadrant. What is area of a quadrant? Pi r square by 4. Suppose in this also you can expect a question. So you can expect a question. What is the area of this shaded region? Observe carefully. In area of a quadrant, remove area of a right triangle. In area of a quadrant, subtract area of a triangle. You are going to get the shaded region. Like this, any figure, children, try to understand the figure carefully first, right? If you're able to understand the figure, okay, this is a shaded region, I need to calculate how I'm going to get, what shape I can see, if I remove which part I can get this shaded region. Like this, if you're able to understand, then it will be very easy for you. Areas related to circles is very easy when you remember the formula and understand the figure, imagine the figure carefully. Okay, with this, I'm going to end the session. We are going to meet in our next session. Until then, keep watching. Thank you all.